You know that feeling, right? When you're wrestling with an AI, trying to find just the perfect combination of words to get the answer you actually need. That's prompt engineering as we know it. But what if I told you that whole frustrating process is about to completely change? In this explainer, we're going to dig into how we're moving way beyond just typing words into a box and into a whole new era of interacting with AI. Okay, let's just jump right in with a phrase that captures this huge shift perfectly: programming, not prompting. See, this isn't about getting better at writing flowery sentences anymore. It's about becoming a kind of systems engineer, designing robust, reliable ways to actually steer these incredibly powerful models. So, let's start with the real problem here. Why is the way we're all talking to AI right now, this manual, kind of messy trial and error thing, why is it actually holding us back from what these models can really do?
Well, it's because, let's be honest, manual prompting can feel like a bit of a dark art. We're all just guessing, hunting for those magic words. It's totally inefficient, it's inconsistent, and it's pretty much impossible to scale up. You find a prompt that works great one day, and then the next day, on a slightly different model, it just completely falls flat.
And this is where the solution starts to take shape. We're making a move away from an art, something that's manual, brittle, and inconsistent, and toward a real science, something that's automated, that's driven by data, that's robust, and maybe most important of all, that's reproducible. This is how you build a real engineering discipline. So, how in the world do we make that leap? Well, the first big step, and honestly the most exciting one, is to teach the AI to become its very own prompt engineer. So instead of us searching for the right words, we build systems that find them for us. To pull this off, researchers are basically tackling the problem from three main angles. First, you've got these evolutionary methods, which kind of mimic natural selection. Then there's reinforcement learning, which is all about using a system of rewards, like training a dog. And finally, there are gradient-based methods, which are like performing super precise surgical tweaks on the prompts. Each one has its own unique power. Now, to see how this actually works, let's check out this fascinating example called Prompt Breeder. It literally uses the principles of evolution. It creates a whole population of prompts and then has them compete. Only the fittest ones, the ones that work best, survive to mutate and create the next generation. And this is where it gets really, really clever. It doesn't just evolve the prompts to solve the task, it also evolves the instructions for how to mutate the prompts. It's this incredible self-referential loop where the system doesn't just get better at the job, it gets better at learning how to get better at the job. Wild, right? But, and this is a big but, all that evolutionary power comes with a pretty steep price tag. A single full run can take hours and cost close to $60. So, yeah, it's effective, but it shines a huge spotlight on a major bottleneck. These automated methods are incredibly hungry for resources. Now, other methods, especially those using reinforcement learning, have stumbled upon something truly bizarre. Sometimes, the absolute most effective, highly optimized prompts look like complete and utter gibberish to a human. This is a huge insight. What makes perfect sense to the model's internal logic is often completely alien to our own. And that discovery, that the model's logic isn't our logic, is what builds towards a much, much deeper idea. We're moving beyond just asking for answers. We're getting into an era where we treat the LLM as a complex system that we can actually actively steer and control. This is where the language of something called control theory gives us this powerful new way to think. So in this view, the LLM itself is the system. The conversation history, that's its state. And our prompt, that becomes the control input we use to guide the output. See? It totally reframes the entire interaction. And thinking this way leads to a really mind-bending idea. They call it the magic word hypothesis. It basically suggests that for almost any answer you could possibly want, there exists a short, perfect prompt, a perfect control input that can literally force the model to produce it. And get this, it's not just a theory. Research is showing that the right answer is reachable about 97% of the time with a really short prompt. It's almost always right there, within reach, if you can just find the right lever to pull. So this new science is incredibly promising. It's offering a level of precision that we've just never had before. But like with any major leap forward, it also uncovers a whole new set of really complex challenges that we now have to figure out how to solve. Yeah, we're facing some pretty significant hurdles.
Beyond the high cost we talked about, prompts that are optimized for one model often just completely fail on another. And there's also the risk that all this automation could accidentally corrupt what the user was actually trying to do. But woven through all of these is the single biggest challenge of all, just ensuring reliability. To tackle that reliability problem, researchers are coming up with new ways to measure performance. One of the key ideas is something called semantic stability. It's a metric that checks if a prompt consistently produces the same meaning in its output, even if the exact wording changes a bit. It's a formal way to measure if a prompt is truly robust.
And that really brings us to the ultimate takeaway here. This is not about blind automation. It's not about replacing the human in the loop. The true goal is to build an engineering discipline that creates intelligent tools to preserve and even enhance human intent. It's about making our interactions with AI more powerful and way more predictable.
All of this incredible work is pushing us toward a future with an amazing amount of control and precision, but it does leave us with one final, pretty profound question to think about. If we can build systems that perfectly steer an AI, what does it mean for us to be the ones holding the wheel?